from civil missions in Europe. When you look on the right-hand side, you see all of these new launches that are happening on the commercial side. And the majority of these are Earth observation satellites that each are able to collect information about the planet in different spatial resolution, spectral resolution, as well as update frequency. So there's a tremendous amount of data that is being collected from space. And it's going to continue. Here we have what the European Space Agency has in their hybrid architecture, looking at a variety of different phenomenologies. Whoops, sorry about that. Thank you, Simonetta. That was my phone. A variety of phenomenologies in order for us to understand the changing planet. And it's not just the European Space Agency, but also NASA's Science Mission Directorate, with a variety of not only demonstration missions, but very large, very, very hard to measure phenomenologies about the planet. And the whole reason why we go to space in order to sense the Earth is to make sense of all of that information so that we understand what that means. And this is what I really wanted to kind of give us a framework of thinking about data fusion. By the way, this is not exactly what is industry standard for the right terminology. We're still figuring it out together. So this is really just my point of view of thinking about the different definitions on different levels of data. So a level 0 data product is like when you take a picture, it's the raw picture. And then you need to act, and it's really heavy. So it's a really, each picture weighs a lot. You know, it's not just a number, it's a picture. So it's hard to transmit that over the internet. When you get to level 1 data products, these are standard remote sensing formats. And it needs to be scientifically valid and credible. And the opportunity here is to turn these level 2 data products into something that's called analysis-ready data. And tremendous amount of work by the Europeans, by the Americans, and by industry alike have started to come up with these standards together to create a level 2 analysis-ready data product. That is still a picture, so it still is heavy amount of data. And you need to be a remote sensing scientist in order to really make good use and understanding out of it. Level 3 data is a bit of the pivot point, where it takes remote sensing data from different sources and turns it into one unique data set. It still is a remote sensing data product, but it has pixel level provenance where you actually understand where the data is coming from. But the reason why I think that is where our industry is today, is taking level 2 to level 3, is what's to come with level 4 data products. This, to me, is when we're going to be able to unlock the economic opportunity of Earth observation downstream, in addition to greater societal benefits. Because level 4 data products are when you go from pictures to numbers. And numbers are time series of information. And then that allows for software developers and data scientists to get contextual, real-time understanding about facts on the planet for a variety of applications. And this is where we can digitize our workflow, part of the digitization transition of the global economy, which is affecting every government and every business around the world. But then also, these are Earth indicators. These are things that help us understand what's happening on the planet from an environmental transition. So I'll end on this in a second, but I want to go through really quickly a few examples that us here on the panel have been working on. Underneath it, this is not very sexy for those who are in the world of standards, but it is necessary. This is what has made it possible to get to analysis-ready data, is the community coming together in order to create interoperable data standards. So there's something called cloud-optimized geotiffs, spatiotemporal access catalog, and quite a bit more common qualifications across analysis-ready data. Again, that gets to level 2 in order for us to then open up the opportunity for additional applications. The Landsat program is celebrating its 50th year this year, and they've been able to get toward level 2 analysis-ready data as a standard product. And that just makes it so much easier for people to have access to this archive of the changing planet. Working between NASA and also with the European Space Agency, operators and actors are beginning to harmonize the analysis-ready data of Sentinel-2, which is electro-optical, and Landsat, which is also electro-optical, in order to create a synthetic data product that is scientifically valid, that then is greater than the sum of both parts together. So this is a 2 to 4 day global coverage of about 30 meters per pixel of the changing planet by putting these two different data sources together. The European Space Agency has more than just electro-optical data from Sentinel-2. They have radar data from Sentinel-1, understanding climate variables coming out of different phenomenologies. But the point is, when you can combine cloud computing technologies with these analysis-ready data, you can see time series over time in order for us to understand the changing planet. And this is really an awesome visualization, and we need to get it to a point where it's bite-sized pieces of technology that then allows for developers to get access to this contextual information about the planet. This is an example of something that came out of an education and research community, a C-STEM algorithm. What we were able to do is to take, this is that planet example, we were able to take MODIS data, Landsat data, Sentinel-1 data, and Planet Dove data to create a cloud-free picture of the planet every day. But while it's pretty, what's really useful is that you're able to get to the point of numbers. So this shows chlorophyll content in crops. And this is just an NDVI indicator that then goes into a business intelligence tool to allow for a farmer to understand when to cultivate, when to put additional fertilizer on, and when to actually apply additional water to their crops. We have Grega up here from Synergize. He's been working on taking a lot of the Sentinel-2 data via the Sentinel Hub and allow for developers in order to harmonize data together and create their own models. And this allows for you to actually see through quite a bit of the gaps that you would get from any one data source. So combining those things together, you're able to actually see things between the gap, and in cases, that's actually a very, very viable thing for farmers. In this case, it shows that you miss a mowing event when you don't combine these two things together. And the last thing I want to mention here is a lot of the work that Amazon Web Services has done on this. Cloud computing is a global utility. They've been able to take all of the Landsat data, a lot of the Sentinel data, activate it to the cloud to really make it easier for people to not download data, to allow for people to build new sense-making applications. So that's where I wanted to stop today, just as a little bit of context. So in summary, we are going through a massive sensor revolution. It's happening in space and on the ground. That's collecting near real-time information about the planet. Putting that data into standard formats will then allow for us to keep the data integrity from a scientific perspective, but then massage the data to get to numbers that then allow for new developers and business analysts to get access to information about the planet that then they don't have to know the remote sensing science or tasking a satellite in order to get then their business applications or their societal value. So with that, thank you, and I look forward to the discussion.
Thanks so much, Robbie. Thank you.
Nice slides.
Thank you for giving us context. This is, it's important to know, to remember that Earth observation is not just about pretty pictures, as you said, but really the numbers, the information, and creating a product and creating a downstream economy. But I'm curious what other speakers have to say about that. Simonetta, maybe I'll start with you. I know Isa is working on digital twin Earth. We're talking about revolution. I mean, this is revolutionary. This hasn't been done yet, to actually put a digital twin of the planet Earth. How are you leveraging fused data sets? And I'm not just asking about Earth observation, but various data sets, yeah.
Yeah, thank you, Agnieszka. Thank you, Planet, for organizing this session. I've already seen quite a lot of what we do through the slides that you just presented. So the situation with ESA is the fact that today we have 15 missions in operation, but we also have 30 years of archives, not only of ESA missions, but also third-party missions, which means there's a huge wealth of data in terms of Earth observation data available through what we have in terms of both archives, but also missions in operation. And we have 41 satellites which are planned. Just to give you an indication of volumes of data, we have today 300 terabytes per day of Copernicus Sentinel data, which are downloaded by users, over 500,000. So the challenge of integrating different data sources, we saw here the integration of various data sources from various missions, commercial missions on one side, institutional missions, national, European, American. It's certainly a challenge for all of us collectively. And that's something we've been working a lot for many years in terms of working on common standards or developing interoperability schemes. And we've done this through CEOs, for example, through the Committee of Earth Observation, working with all the international partner and space agencies on common standards, or also on RD, so also on basically analysis-ready data sets that are ready to be worked on. The integration of the data sources is not just from the EO, as you correctly said. It's also the need to integrate those data with ground data, with also data from planes, all sources. And what we are trying to do now with ESA, we are trying to use this wealth of data that we have available to include it in a new initiative. The new initiative is the digital twin of the Earth that you just mentioned, is the fact of valorizing the data wealth that we have from multiple sources and putting that with combination of high computing capabilities into systems that can allow and can support us in terms of prediction and modeling over different topics. We are, for example, right now working on a test case which is on Antarctica to look at modeling and forecasts and predictions related to that region. We're also working on an initiative which is very complementary to the digital twin of the Earth with the European Commission. It's called Destiny. It's an initiative led by DG Connect, which is the Directorate General in Europe that deals with the digital agenda. So we are also trying to look at these challenges, trying to go beyond the traditional Earth observation world and connect it to the world, the digital world, which is not our traditional field. And that's also part of the challenge that we're having today. So that's where we stand. We have a new initiative. It's going, this digital twin of the Earth, to ministers for European countries to subscribe in the coming months at the ministerial. But we really look forward to enhance our capabilities. We have also developed what we call the Eurodata Cube, which is a platform that provides data sources in terms of integration with AI capabilities. And this data cube has been used in the collaboration that we have with NASA, with JAXA, on working on demonstration of application topics related to environment and agriculture in the COVID crisis.
Thank you so much, Simonetta. This is quite fascinating. I think we'll all be watching how this digital twin Earth is developing, and hopefully some of us can partake in the endeavor, because as you said, you will need all kinds of data sources. Grega, you are dealing with a lot with Sentinel data, but also you have experience in data fusion. What is your experience and opinion on using different data sources, so not just Earth observation, but combining it with something else?
Well, first of all, that it's quite challenging. I mean, there is this technical challenge that Robbie mentioned, that you have just a large volumes of data that you need to combine. But that's, I think, is more or less solved with the cloud technology that is available. The challenging part, there are basically two steps that are relevant. One is how to harmonize the sensors from the same, from the even electro-optical satellites like Landsat and Sentinel, which are very much alike, but they are not the same. And if you just combine values together in a time series, you'll get a lot of noise. One thing that is very important to consider is that when we are looking at the fusion, we are not really interested in snapshots, right? We always are looking into the time series, and we are looking at the time series over a large area of the world, because this is where it gets interesting. And now when you start combining different data sets together, any kind of step that makes it, let's say, more harmonized is super important, because then it allows you to generate good models on the fused data. The second challenge that is there is what to then do with this fused data, because that is, I mean, we have lots of ideas and the initiatives like Digital Twin of Earth are helping in this direction, but there are very few things that work, let's say, on a semi-operational level on a large scale. You have some experiments that work here and there, but when you start working on things that should be scalable, this is where it gets challenging. And I mean, one of the things that we do have in Europe is this supporting for common agriculture policy, where we actually want to monitor, we as a European Union, want to monitor all the fields, agriculture fields, whether they are like operated in a sustainable manner. And this is where you immediately bump into the issue that having just one data source is not sufficient. You have clouds, then they would say, you go for Sentinel-1, but then Sentinel-1 fails, and then you need to go for something else. And here is where the fused data becomes essential, because only with the combined source you can actually start getting some operational value out of all this data.
Thank you. Bill, would you like to add to that conversation? How do you see it? What are the actual limitations here?
So as the infrastructure provider of sorts for all of this collection and analysis, I 100% agree with my colleagues on the need for standardization, because we have 26 regions around the world, all connected at 100 gigabit per second fiber, but sorting the databases in all these different formats, as opposed to getting down to a set of primary standards formats it's quite challenging. And so we can't get to scale because we have too many things to sort. And in the sorting, as sort of Gregor referred to, if you lose time, after a while, you lose value. So I first would heartily endorse the concept of getting to wider standards. And then secondly, to think about how we can combine these multiple sources, electro-optical, SAR, other sorts of remote sensing, including RF and other things, so that in building the digital twins that you're thinking about, that we can have inputs from ground to space and then anything in between, and be able to feed them, because they are standardized, into common models that can run at high speed around the world. And so that if we could approach that, we envision ourselves and other cloud providers as being able to afford all that on a global basis. I have this grand vision of the real matrix that involves near real-time digital twinning of the world on every sensory level, so that you could literally track in times of disaster, war, famine, other sorts of things, everybody and everything that's moving in a space against climactic information, against tide, against water temperature, against all the other factors that would impact that movement. And so our request, our support, is for increased standardization and increased utilization of our open data resources, which are essentially open to public sector for use.
Yeah, thank you. Definitely. I mean, we like standards. Robbie likes standards. It's definitely something that we need. And Thomas, you at NASA, you have access to a lot of different data sources and different products. What is your vision on the topic and data fusion?
Well, look, I'll start with an anecdote, and that is that, I graduated 20 PhD students. Many of them worked on space data. And it took me between 6 months to 12 months for a student usually to kind of really be able to use the data and actually do actual science with it. Right. And that's a year lost, I would say, largely speaking. So I mean, by the way, I was in one of the top universities, right, and very smart people and so forth. That hurdle that we're putting ahead of it without that standardization, without the fusion, without the harmonizing of the data, is enormous waste of talent, and becomes the hurdle why many socioeconomically depressed kind of communities, or the ones that are most in need of having climate data, are actually not having access to the data. So for me, the vision that we have is an open science vision, which is really looking at all of these issues in a coherent fashion. Very much, we have perhaps slightly different words than Simonetta is using, but very much aligned in vision overall. Also, if we're talking, of course, to our commercial partners the same way. I want to stress 2 or 3 things. First of all, the only way this will ever work is that open science, open data are the standard. What I mean with open data is, of course, the obvious thing is the only thing that our colleague can put on the web service are data that are actually usable. We have, of course, in NASA been the leaders in making the data open. ESA is very much aligned with this. I just want to point out that there's a number of entities that are not making their data public.
Yeah.
Right.
And what's really is critical is that the data are public, because many of these spacecraft, frankly, fly over areas where the data are not really useful in the context of the data being closed. Because, again, our spacecraft also fly over Europe, over Asia, and so forth, low Earth orbiting spacecraft. And so making the data public makes the data more useful. What we mean with open science, of course, which is the next standard, is that when in a publication or in otherwise kind of algorithms get found that actually help us turn these data into scientific products, whether that is, the kind of stuff you showed, Robbie, with agriculture, work that you showed in the animation, from Simonetta, that relate to oceans, those data, these algorithms, for them to really be scalable in the context of web service and kind of cloud computing, that the algorithms need to be out there, right? Because otherwise, we can't, even in the best software, we can't have every kind of the Earth in every single possible algorithm. We need to empower individuals to use these algorithms. And for us, the reason we're so passionate about, again, is not only because that opens the access. It's one more thing we want to talk about, and I mentioned it a little bit with my anecdote, which is the sense of urgency we have. It used to be that Earth science, and a lot of the work we did, kind of everybody basically thought we had decades. And frankly, I talked to leaders in my position. I'm sure you did the same with yours. By the way, I'm just so excited to sit next to you in your position at ESA. The partnership between ESA and NASA couldn't be stronger on these, and the alignment on this, and just you being a champion of that just means a lot to all of us, our entire team. But we used to have decades. We're not in the decades anymore. Frankly, it's frightening, whether it's threats like fire, whether it's issues that are plaguing us today, that frankly we can tell on the timescale of years, small number of years, are substantially changing the scope. For us, these things are imperatives. They're not really, for us, things that are options out of many, many different options. They're imperatives because we cannot catch up with how fast nature is evolving otherwise.
Yeah. I think what you just said there, it's a key. We're not just speaking here about theory. We have real issues that are happening now, and I think it's very good that you highlighted the cooperation that you have with ESA, that it takes cooperation to deal with these problems, that we cannot fight it alone, and it should happen on both sides of the ocean and further, and it should include public and private sectors. We are in this together, and we can do so much more when we actually work on this together. Robbie, so I have kind of 2 questions for you. One is because we've been talking about standards and how realistic it is that these standards become standards in your view. And the second thing is, where do you think Planet is going when it comes to data fusion and
Yeah, so well, first of all, I'm glad that other people are just as excited about standards as I am, because I think that that's what creates an ecosystem. And we're not really making this up in the Earth observation community. If you take a look at any type of industry that's undergoing massive growth, standards become key for actors to specialize, for actors to make things interoperable. So if we take a look at how the internet really went from being something that happened in university labs and had some government support and activity to then all of a sudden turning it into a global utility that we all use, it was the Internet Engineering Task Force that really made that possible. The actors who were playing with this new technology would then get together, the engineers would get together, and they're trying to solve problems and they share solutions with one another. And this is all like the back end stuff that is not a differentiation for a company or for a country or anything like that. And then when you share those things together, then you end up choosing the best, most efficient approach that somebody did, and it becomes the standard. And I think that that's actually how the two that I mentioned, Cloud Optimized GeoTIFFs and Spatiotemporal Access Catalog, came about. You had the major actors who were holding on to a whole bunch of data, trying to put it onto the cloud, came up with the right type of metadata and structure in order to make it most efficient. And so these, I think, are like the level 1 standards, and we're slowly getting up to more of the harmonized standards, and that has to be based on papers that are published, forums that are actually bringing the right actors together to then share one another's lessons learned, and then you actually come up with a new standard by the actors who are doing it. It's not legislated by a government body. It's actually done by the actors, and that's why it needs to be something that is across public sector and private sector. So where I see this stuff going, I guess I mentioned it in my pretext to what I just answered this. I think this is going to an ecosystem. I think if we take a look at the global commercial space industry, it's, depending on which report you look at, it's on the order of 350 billion euro addressable market across launch to telecommunications to Earth observation. And the mass majority of that is in telecommunications. It's whatever, don't quote me on these numbers, but it's on the order of like 25, 30 billion euros for launch. Earth observation is around 5 or 6 billion euros, and the rest is telco. But the value of telco is in the downstream services. It's all of the companies that build modems, that build other activities that then utilize the power of space, and in this case, connectivity. And that's where I see things going as we as a community, powered by the urgency to act for climate action, are going to be able to create an ecosystem of downstream users. And again, it gets more toward the level 4 data products, where then software developers can get access to these near real-time information about the planet. And then I think the downstream ecosystem will really thrive.
Thank you. Thank you, Robbie. By the way, if anybody has a question, please raise your hand. We also would like to take some questions from the audience. We're going to continue chatting here, but feel free. Grega, what kind of initiatives would you like to see coming from the public sector to kind of help with these challenges of using data fusion? Simonetta is taking notes.
So then how much time we have? No, but I think, one thing that is very important is that we make the data that, if you are talking about the fusion, right, which is, as mentioned previously, very complicated, that we make fused data really easily and operationally available. A nice example is the harmonized Landsat Sentinel dataset that is available on AWS, and anyone can use it, and it's regularly updated. I'm looking forward to see the European side doing similarly, with obviously better resolution, because Sentinel is a tiny bit better than Landsat. So that's the first thing, that the data that are available, that are harmonized, are really available like in an online way. Second is that the tools that we are making are done in a way that can be used in a cloud-native way. The times when we downloaded the tool and the data to our laptop and run it there, this is no longer working when you want to work with large volumes of data, as we said previously. So we need to have tools that can be run either in a like instant manner that you say, I would like to get harmonized data between Sentinel-1 and Sentinel-2 as an example, I'm just imagining, immediately, or they need to be in a way that we as a infrastructure or platform provider can integrate them in the cloud infrastructure in a way that it will just work. Because if we just have tools that like need a lot of tweaking, this just doesn't work well. And then just making this science part, which I think is super difficult, of how to actually compare the different sensor values, well, different values from different sensors. That's something that for us as a private entity is probably just too large task to handle. And this is where we would hope that the public bodies step in and develop research and obviously publish it.
Can I ask a question to some of the speakers there, especially you were speaking? I'm really, kind of from a point of view, I used to run programs with startups. I never funded a startup that did not actually talk to customers and understood what the customers actually needed. And have a really good understanding, had interviewed them, and I even had some customers that were ready to take the product and use it once they were developing the product. So how do you know what's actually needed exactly as the end product, and how do you do it at scale? What's so hard about the earth, right, is kind of the farmers in Michigan are different than the farmers in the Swiss Alps. Trust me, I live in both, have lived in both areas. They're really different, so how do you do that kind of customer development? How do you create that scale so at the end you actually have the product that matters?
I mean, first of all, I don't think that this is solved problem already. Most of the I think there is a significant disconnect between the data that is available and the usage that is happening with this data. And one of the reasons is that it's just very difficult. And here there are many parts of being difficult, from scientific to technical ones. That said, what we try to do is make the data available in as easy manner as possible, so that our customers are not farmers, as an example, but they are the application developers who work with the farmers. These application developers have no knowledge about satellite data. I think that's already a success, that we were able to bridge this gap and get the data or the products to the people who don't understand satellite data. At the moment, most of them are still working with a simple NDVI. And in many cases, it works well, right? But again, NDVI is just scratching the surface. So we want to expand this by orders of magnitude so that they get the ideas. And this is, they stumble into the problems of, why is there the data from, a week ago so much different than now? And they don't understand that, this is because, it's a different sensor, or it was cloudy, or something like that. So this is, because of the data being so challenging still, there is still a lack of viable ideas that can be developed on it. I think it's changing quite fast. Like in the last 2 years, things are progressing very well, but there's still a lot to be done.
Really, so it's part of the answer is the who. Who is your customer? It's not the end user. It's the exactly right. Yeah.
So I could say to you, though, in line with your question about how do you know what the customer wants. So I work in the satellite solutions team. We support a direct customer base, but then anybody who has a question or an inquiry around Earth observation data, telecommunications, building a satellite, anything, it all comes through our group. And we get questions from the account teams that manage the utility companies. How can I go buy as much data as I can on power line and foliage? And we get questions from car makers about car populations. And we get questions from insurance companies and banks and other folks. Again, coming through their account teams, do you have access to different streams of information So we can do analytics around insurance rates in a particular city, that sort of thing. They're literally counting cars, or they're looking at how fast buildings are going up, roads are getting constructed, that sort of thing. We get questions all the time in the public sector from governments asking, could you organize 3, 4 different looks at my borders? I'd like to understand my maritime domain awareness. I'd like to understand my border awareness. And all of it from a satellite and other observation capabilities.
I think it's every single one of those use cases can be a new business.
Right.
Right? And even that first one is a real business and is a graduate of the Copernicus Masters Program here in Europe and a partner of Planet, which is a Berlin-based company that's called Live.io. They just focused on one use case within a sub-vertical, within a vertical market, which was foliage over linear power lines. And they've been doing this for like 3 or 4 years, combining a whole bunch of different data sources for that one use case, and they're killing it. They just raised an $18 million Series B earlier this year, focusing on one thing to deliver business value for end customers. Now, importantly, they're now able to tweak a little bit of their workflow internally and come up with 3 new products, right? So, but I think that the main thing is to be use case focused in developing those applications.
And also on the side, for example, of ESA, an anecdote also on my side, when I started to work with Earth observation, we used to have spot data supporting the Eurostat statistics, the monthly one, and we were giving radar data from ERS because there were areas where you had gaps you couldn't see because of clouds, and that was Portugal or Ireland. Today you can do the combination of all of that, so you use the Sentinel-1, 2, and all of that in these fantastic data fusion systems and integrating different data sources, so you don't even think of giving just the radar data as a complement to an optical one. It's interesting to see that we've been working a lot with the users, trying to understand at best first institutional user requirements. For example, in Europe, we looked a lot at the common agriculture policy, not only what they needed in terms of statistics and in terms of sources of data, in terms of type of sensors, in terms of repetitivity of the coverage, but we've also tried to support the definition in the commercial sector of new products which were tailored to those user needs. For example, not only you have crop statistics of crops now available, but we worked with the Czech Republic a few years ago to look into all the classifications of the crop, and this methodology has then been used Europe-wide for the implementation of the Common Agriculture Policy. Or we work with FAO, trying to understand where they need to tackle food security issues, and there you can also use satellite like SMOS, which look at the soil moisture. By the way, it's also used by the American Ministry of Agriculture, soil moisture, to look at the humidity of the terrain. So you have, I think, a huge variety of potential business cases to develop. And what we like to do is to work with a mix of the commercial private sector, let's say, initiatives, and also the public sector requirements. And if we can manage to do that at best, and I hope we can do that further, teaming up with people like you, I think that will be the success story. It's a success story in terms of commercial perspective, but also it's a success story for everybody, because I think we need in climate change, we need citizen science to integrate also the data we get from the satellites, so even people can see the relevance of the data they get from the satellites if they help on the ground to check that those data are valuable. And we fully support the approach that was mentioned by NASA of an open science approach with free and open data policy, because that's essential to foster the domain and to foster this sector.
Yeah, I think one of the takeaways that I got from this exchange just now is that we need to get to know our users. We shouldn't just be speaking to each other, but speaking to those who actually will benefit from what we're producing. We shouldn't produce what we think is cool, but we should produce what is really actually needed. That's the way forward. I saw a couple of questions. There's a gentleman in the back first. Do we have a microphone?
It's coming from the back.
There's somebody else.
There's also a mic here.
Hi, this is Andy from Cedric Initiative. I believe that some of the limitations for time series forecasting was mentioned, but I also believe that univariate data is a very big limitation. And I believe that like services like Planet are providing APIs in order for businesses to tailor their own solutions and their data to provide solutions to the users. I just wanted to know if there's any plans or in the future to add any multimodal data on your portfolio?
So the Planet, the way that people access Planet data today is via an API, for sure. But we also do allow for it to be querying the same API format data that's coming off of AWS if Landsat is stored on there, Sentinel-2, et cetera. And I think that like if you go to any one of the data providers that are out there, you go to their domain name /docs or docs.domain name, people are beginning to get to a common format across actually how you query through those things. So you can query multimodal data as it is today. And I do think the opportunity, though, is still 1 to 2 years away, is when we get toward the standards for level 3 data products that then allow for developers to upload their own training data, so ground validation data. They upload that themselves, query across level 3 data, and then create their own analytic, their own model. And then when you run that, it creates a level 4 data product that's custom to you. So that's getting more toward a platform ecosystem that's an innovation platform. And there are a variety of tools that are out there in order to get toward that, but that is, I think, where the direction is going. So you can query multimodal today, but it's that all the building blocks aren't all together into one sweet location that then will really unlock the innovation ecosystem from developers, but that is the direction where things are going.
Okay, thanks.
Philippe, and then you had a question?
Yeah, thank you. Philippe Campenon from Planet. I have a general question about, we have been talking about how to make the data simpler to the users, but all of us in this room, we are all from space industry. We are talking among ourselves. My question is, how can we be seen from other industries, people who don't know about us? Gregor, you were mentioning NDVI. I think if you go in the street, you ask people about NDVI, nobody knows what it is. And so we need to move to standards, but we need to move to something that is understandable by people who are far away from our own industry. So my question to all of us is, what should we do to be known as a source of information outside of the space world?
I can try to comment on that. I think that Simonetta nicely mentioned this idea of translating the data into something, like in the case of common agriculture policy, in the products that basically are no longer related to the satellite data. I think this is where we need to come to. Like as an example, we do similarly, and we translate the Sentinel and the Planet Fusion signal into the mowing events or harvest event or the bare soil events. So I think that if we want really to make the satellite data used as much as it should be, we should translate it into something that is no longer related to satellite data at all. Saying, look, I mean, if we provide information how many events were this agriculture parcel, then people will know how to translate this into the business, right? Or the live VO, they probably are working on what is the height of the vegetation under the power lines. So again, we need to create this, what is the variable, the planetary variable, I think is the term that I see with at Planet, which people don't really need to know and understand the satellite data to actually make use of it. Then I think this, and there will be a ton of this, right? Let's be clear, there will be hundreds of different variables, and each of those can be its own business model. And we just need to put a lot of focus into creating a set of those so that we spark the imagination of others to start following and creating their own variables.
Thank you, Grega. We had a question here. Yeah.
Okay, so I'm Dimitris Blisiotis from the Greek Space Agency and Earth Observation Officer. I have a general point of discussion more than a question. Taking into account that many private missions in the new space are coming from small sats or whatever, what is the plan in order to be able to data fuse also this data, but not only big Sentinel family data, Landsat 8, Landsat 9, how are going to guarantee interoperability both in the spectra but also in the data infrastructure? Is there a plan, a quality, a standards that the new providers, the new space has to adapt on this end? It's a general panel question, it's not direct to someone. Thank you. And I know Planet has done a lot of things in Sentinel-2, integration, interoperability.
So, well, I'm not sure we understood everything, but there's a bit of an echo here. But what you're saying is that when we're talking about data fusion, we shouldn't be just focusing on those big data sets coming from...
No. I'm asking how we're going to handle the proper data fusion between the new space, the new private missions that are numerous, and the big milestones that we have as Sentinel, and if there is a timeline, a roadmap for this goal.
So how are we going to assure standards?
Exactly, yeah.
Is that what you're asking? Yeah. Anybody? I think we're just...
Maybe not on the standard point specifically, but on the point, for example, we in ESA, we see the new commercial initiatives and the new constellations or satellite, like the data it's offered by Planet, as very complementary to the Sentinels, for example. So that's the way we see it. So in terms of complementarity, that's the approach we're taking. Just an example, for the Copernicus contributing mission, you have the Sentinels, which are the core of what we do, but then you have all the complementary mission, the contributing mission, which can be either third-party mission from other agencies, public agencies, but can also be privately commercial data coming from data sets like Planet is contributing mission or others. And this is really an approach that we're taking more and more in terms of trying to integrate all the data sources, because at the end of the story you need to support a service which is a land, a marine service, and you don't care where the data comes from, provided that it's useful and provided it in the end you have the product that you need to have. On the standardization, at least on ESA side, we've always worked, but mostly in interaction with public, but we are really tackling now this new commercial sector, mostly on the side of trying to initiate support to new commercial initiatives, anchor tenancy schemes to buy data, or support to technology development, opening to markets, favoring partnership among new commercial initiatives. On the standard side, I mean, we don't have the solution yet, just to be very blunt, but we are really actively discussing with the new startups what can be done to make sure that these data are all interoperable or interexchangeable.
Yeah, thank you, Simonetta. And I think what Robbie said earlier, that the standards are not going to be, I guess, set by a government, one particular government, but it's going to be something that is going to be done by the actors. So if those new space companies want to be part of that data fusion community, it's going to be in their interest to meet those standards. It's in our interest to meet those standards so that we can be interoperable and so that we can do data fusion together. Otherwise, you're just not going to be able to engage. So hopefully that's going to speed up the process. But I know, Grega, you wanted to say something.
I just wanted to add that, I mean, we shouldn't and we don't need to wait for these standards to arrive, because the data as it is there is already useful. And one way of standardization will be simply in having platforms which provide APIs, which are standard per se. Again, Simonetta previously mentioned the Eurodata Cube, which is actively working on taking data in the form as they are, like typically, I mean, they are not standard form because you have different data, and translating them in a set of very few API, one for vector data, one for raster data. And when you have an API which has a fixed set of parameters, this is a standard per se. Now, obviously, you'll have a few platforms out there which will have different set of APIs, but these platforms are actually simplifying the access to the data as it is now. So I think that you can address this standardization issue while it's happening by simply making an API on top of it.
Comments?
So I want to just double click on something you said, Simonette, earlier, and of course we've been at this for several years now. I really believe that for many of these standardizations and kind of the broadening to a global place, actually, business partners are going to be very important.
Yep.
Because frankly, businesses, like we have government solutions, and you know, if you work for the U.S. government, of course, the citizens in the United States are the highest priority, as are the citizens of France if you work for the French government, and other countries. So I think the platforms that go across, like the observing platforms that go across, we want to contribute to that ecosystem by providing that value of open science, like we said. But for me, it's absolutely essential that kind of commercial entities are really doing both, really providing data that are repeatable or kind of uniquely positioned for commercial markets. And it's on us, right? And we have practiced with multiple iterations, kind of making that data available to the research community. In addition to that, it's also important, I actually believe from organizations that know how to scale tend to be commercial partners, kind of across boundaries. So I think that's another downstream market, as you called it. I want to point to one thing that maybe sound like really orthogonal, but it's really important to me that we mention it, and that is that we should not pretend we already know how to observe the Earth in the perfect fashion. Kind of in the last few years, we've made first-of-a-kind observations, whether it's of ice with ICESat-2 with 2-3 millimeters height resolution and a lateral resolution of 1 meter, which used to be 100 meters, or kind of many centimeters in the other direction. Kind of the advent of kind of really advanced hyperspectral data that is both in the government side, but also with the EMIT at the space station, but also in commercial entities there. Also, I would really like to know, as we look at water distribution below the surface, we're using gravity missions. I'd like to know what quantum sensors can do for that as we go forward and really advance that. I mean, I would argue that this is where we as government investors, we should really drive towards that. Now, once we figure out something as important as evapotranspiration, right, detecting the health of plants before they go dead, turn brown, that speed, kind of recognizing that happens until it's really useful to the farming community, that is the time that needs to shorten, right? And so for us, really building an ecosystem that's connected at the hip, in which we drive towards kind of, putting more kind of tool sets on the inside of what's now known as opposed to the outside, but then really using with new partners, really making these things available. And I just want to stress the importance of cloud computing and all the kind of technological sphere there. I think, to me, that's really, I think, what will give us actually the tools that we need. It takes all of that.
Yeah, absolutely. So, actually, following up on that, on cloud computing, Bill, do you think we have the capabilities? Can we handle all those data sets, fusion data sets?
I do. I think Robbie has a view on this in particular in terms of promoting cloud native applications and making sure that the ARD, the data is ready for analysis at scale around the world. So I'd ask you to comment about that a little bit. But for us, we look at it as if we can get all of the data sets from the sources that make for the ideal fusion, we have the capability from a databasing capability, a compute capability, a storage capability, data laking, and then different tools to manipulate data lakes to make for really effective, fast fusion.
Yeah, I guess I would comment a little bit on where computation is going, and this is, I'm not an expert in this, so, but I do believe that over the history of computation, we've gone from a consolidated and a federated pendulum swing back and forth, where you had one computer that was a quarter the size of this room, That was a consolidated approach, and a federated is when you had your PCs, and then a consolidated is when we have big cloud, and then a federated is when we have IoTs and compute at the edge. And so I think that's when we start to get more toward this as an ecosystem and enabling an API for developers to have access to near real-time information about the planet. We in the back end need to be thinking about what makes sense to be in a data lake and done with, in a huge parallel processing capability versus what can be done right at the edge. And so that's a bit of the architecture that we need to be thinking about with respect to computation to really enable, like, back to Thomas's point around environmental justice purposes. Like when you have an application that's running on your phone, it may be pulling data from a variety of different sources where compute is done in different places to make it most efficient so that a community organizer on the ground can have near real-time information about a methane leak in their neighborhood, right? And so that's where I think the computation is going. There will definitely be a major role, as it is today, for cloud, but I think over time there will be additional roles for compute to be happening more in a federated manner at the edge.
I 100% agree with that. So we look at it as hybrid cloud and edge, and effectively it really is about the speed of the decision making you require at the location you require it.
Yeah, I saw a question over there on the left. You sir, yeah.
Yeah, my name is Mukund Rao. I'm from India. I just want to make a provocative statement to the panel.
Can you put the microphone up to?
Yeah, and to the delegates. In the last 40, 50 years with the availability of data and what is happening, isn't data fusion just creating a sort of a scenario of creating analysis-ready data and stopping at that? So you create the fusion of data from a geometry point of view, from a visualization point of view. But the actual content of the data in terms of its spectral characters or the emissivity characters or the backscattering coefficient of radar data, we are not fusing. So why is it that we are not looking at fusing analysis itself rather than just creating readiness products? So is it not a limitation that we are all posing? And we are not tried out such things. Because the concern that I have is, what are we going to do after fusing all the data? One layer says thermal emissivity is like this. Another layer says NDVI is like this. Another layer says spectral radiance is like this. What do I do with that data? What are the new products that I can get by fusing the content, spectral content or the digital content of the data? I don't think we have done much. Reaction.
Cannot hear.
I mean, one quick comment is that the reason why we are fusing the data is that there is typically not one single source that has all the information, and if you want to unlock others to make use of the data source, you want to provide a fused source rather than the analytics. As an example, Sentinel-2 is a very nice and powerful resource, but it only goes back to 2016. And then you have Landsat, which goes back to 1980. And I mean, yes, you could just share the analytics on each of these two separately, but then you have basically boxed the users into what they will do with this data. If you provide a fused product going from 80s to tomorrow with the capabilities that are, let's say, close to both of these, you now enable thousands of other people with their ideas to create applications that you haven't thought of yourself.
Thank you, Grega. Melania, did you have a question?
Hi, Melania with Planet. Dr. Supergan, you were speaking of your extensive history in academia, and I was wondering if you can comment on universities as a place where not just users, but also the production of standards can come from, especially in the sense of as a mechanism for integrating developing countries into this ecosystem. Thank you.
Oh, I'm a strong believer of the value of universities in that context, and for a simple reason. It's like some of the most caring and most capable individuals that can actually help with that are currently at our universities. They're called students, right? So they're, for me, look, I mean, these issues are getting advanced with the speed of the people who are actually using them and are taking ownership, like some of the examples we have up here, taking ownership of some of these kind of application domains and learning with it, providing back through the open science kind of paradigms back to the collective what they've learned with their own lessons, their own codes, and advancing it forward. So I'm a strong believer also that what really needs to happen and what can happen, which is really an advantage and is very timely, is that our students, even though many of them do publications and very important research, kind of great research results in so many of the earth science teams, that the very students can also be empowered to actually take those data and move it into the domains where they can change the world. I've ran one of the largest programs of that kind in the United States, right, kind of in terms of size, and I just want to tell you, the students are already on board. It's just important that some of the more senior academics get on board also. So for us, it's really getting the tools into the hands of students. But just to answer it in one sentence, universities are a core part of where this advance will happen.
For us in ESA is the same, in the sense that it's part of the genes of ESA to work with the academic world. It's typically the support that we have, not just on open science, but also on the exploitation of the data from the missions come from the academic world. And what we do, we have a very strong synergy between this academic world and the development of new ideas that come from that source and the industrial sector, because we have programs. I think of one of those, it's called Futurio, where you have science programs, science activity exploitation by great scientific work of the data, but then some of those prototype in terms of validation of the applications, in terms of technologies go into the world of the commercial sector, and they do develop inside the academic work as a starting context, but then they go into the commercial sector. So it's a synergy which is very strong inside the agency by nature, the academic world and the industrial world.
And I can say from a commercial perspective, an education and research program is critically important for a number of reasons. One is you get to learn a lot. A lot of the students, they're trying new methodologies, and they publish. They get it out there into then the academic community, which then inspire other scientists to then try something else out. So it's a really, really vibrant innovation community. I can tell you that at Planet, I mentioned this in my remarks, there was a publication called CSTEM that really inspired us to do that level 3 Planet Fusion product. And we ended up actually hiring, that's how we found Rasmus. We ended up hiring him out of the university to come in, and he now has like an 8-person data science team to build that as a standard product. So it's an innovation ecosystem. The other thing too is sometimes younger students don't know that they're solving a really, really hard problem. They're kind of doing something because they see the convergence of technology and they can actually look at what potential new exploratory science that they can do. And I think that that's actually where the innovation does come from. So from a commercial perspective, this is something that we started 7 years ago, but it really kicked off actually with the partnership that we have with Karen and Thomas at NASA with the Commercial Smallsat Data Program, where now every civil government agency in the United States for science purposes has access to it, and their grantees. So that's all of NASA grantees, all of the National Science Foundation grantees have access to this information. And there's now like 2 peer-reviewed publications that are coming out every single day, and that's just like, it's training the next gen workforce, and it's also the hotbed of innovation.
Thank you, Robbie. I've seen that there are more questions, but unfortunately we have to wrap it up. We have like literally 1 minute left, but maybe some speakers, we will see them around. You can keep asking them questions. Any last sentence of wisdom from our speakers? Anybody would like to say something?
I just want to say that I think that what we are seeing and talking about today is really just the beginning, because 2 years ago this discussion wouldn't be possible. And I'm super enthusiastic about the opportunities that this will bring and looking forward.
Thank you.
Totally agree.
I'd add that we're a bunch of space people here. We see the value of Earth observation for society. We think in systems. We think from a planetary perspective. It's a unique vantage point that we have. The rest of the world, as Philippe mentioned, just doesn't know about this. So it also is a little bit of peering into the future. I think in the next 2 years, there will be tremendous amount of tools that will be developed that will then really unlock this for great societal benefit.
Nothing else to add.
All right, all right. Well, this was very interesting. Time flew by. Thank you very much. I think the key takeaway here is that with more data sources, we get more information, we can build more products, more solutions. We should cooperate together and fuse our data. And this is the way forward. Grega, Bill, Robbie, Simonetta, Thomas, thank you very much.
Thank you.
Thank you so much.